Hello and welcome to this short paper presentation about the TGVE, Turing Geovisualisation Engine, a tool for analysis and visualization of geospatial data. My name is Layik. I'm based at School of Computing at University of Leeds. When I was doing this work, I was working with Professor Lomax and Dr. Roger Beecham, who are based at School of Geography at the University of Leeds, but also affiliated with Leeds Institute for Data Analytics and the Alan Turing Institute. Alan Turing Institute funded this research project. So I'm going to take you through the paper, start with an introduction, a background, introduce the tool TGVE, and talk about a particular showcase, and also a little bit of time on the future directions if anyone is interested in using the tool. So when we started the work, we had three particular aims in mind: enabling non-expert experts to generate geospatial visualizations and explore their datasets. Likewise, enabling expert users, but also to integrate the tool into their applications, and hopefully everyone to be able to use a production-ready geospatial application to publish their research output or other datasets. The non-written aim, if you like, has always been a space where we could integrate advanced geospatial visualizations, and I think TGVE provides that space, that framework for any custom geospatial visualization to be used. And the background to this, I see it as data scientists fighting over time, but you, at least in my case, you have data, loads of it, you've got access to tools, but you really don't have a life to spend on learning those tools to generate and just query your geospatial data. And what you're hoping to do is see some sort of maps or some sort of visualization that can give you something about the data, if not being able to interrogate the data. And in real life, this means obtaining various plain text files, say CSVs, but also your geography data, which could be a shapefile, hopefully even more open source, if you like, but inherently large geography data. And then in an R or Python workflow, you would have a tabular format where you would have to, for instance, in a package like SF or GeoPandas, as I understand it, squeeze the spatial data into one of those columns. And obviously the aim is to go back to the top right picture and generate some maps and visualizations. The way the TGVE would do this, first we'll start with an overview, is that in a 2.5 or 3D space, you would possibly have map tiles like this one, or none at all. You will start with an empty world, empty space. The TGVE will then start loading some data, as well as try and make sense of particular columns in your dataset, and then the underlying open source brilliant libraries will start generating some visualization in that 2.5D or 3D space. And as you start interacting with the TGVE, you can start interrogating or exploring further your dataset. And in terms of the actual implementation, this means that we really need to be in a situation where the particular tool can be used both in R and Jupyter environment, but also available on the web if we have to publish our data. And this really means breaking down the system, if you like, into three particular pieces, starting with the JavaScript package, which is available and published on NPM.js, and then integrated that package into an app. At the moment, it's happily living on a GitHub pages space where it can stay. It stays there for free of charge and available to all of us to use. But we've also integrated the app above into an R package for ease of use and also offline processing, because we're aware not everybody wants to or is able to load data from, if you like, an application server or a file server, and also there might be sensitive data to use as well. That then means you need an instance of the TGVE. You also need a source of your data. This could, by the way, come from the user interface. You can interact with the tool to load your data, but also from a URL if it's local or remote, plus minus your geography data if it is not already in your CSV, because you could have point data which typically has a couple of columns for your coordinate references. And not only that, you also would be able to then provide settings and filtering and selection again in the URL, as well as in the user interface, of course. And so in a typical scenario, you have the instance and the data, and then hopefully the TGV will enable you to see a visualization like that one. And in the showcase, this is exactly what's happening under the, let's say, second and third aim of the project. We start with a large amount of simulation data of housing and population of the United Kingdom. The data was about 90 gigabytes of, I think, 12,000 or so CSV files. A large chunk of the work, of course, has nothing to do with the TGVE and means processing and collapsing that data so that it can be served on a conventional server, and I'm talking about one that is here in Germany and has 8 gigabytes of memory. I ended up using the brilliant package R data table to host the entire after processing data of about 50 million rows in memory so that it can be queried in real time by the TGVE. And because the way the TGVE has been designed, we only load the geospatial or the geography data only once, and then subsequently, as users interact with the dataset, we only pull the non-geospatial, non-geography data, and then start on the client side changing the visualization depending on the selection and interaction made by the user. If this is not possible inside your browser, then you can, and I have done it, and it is possible, and there are some documentations about this on the project space, to build the tool, the app specifically, using Rust toolchains into a WebAssembly application that sits natively on your various operating systems and directly on your GPU for extra amount of loading data into the TGVE. Now, the showcase that I'm describing, just to illustrate a little bit more, is something like this. You've got columns like those, then obviously you need a table, conversion, decoding, encoding table to obviously make sense of those numbers with the header there. But eventually we arrive at the image on the right, and the project is available at the URL geospencer.com. It may be shut down in future, so just a little warning there. And this then nicely brings me to the future directions of work, more custom layers. The image that appears on in the short paper and also here is a custom layer that is built on a, let's say, widely used visualization, but with really little effort, if you like. The blue, red and green bars can be anything else, provided that you can define those in the graphics library and then connect those into the incoming dataset within the TGVE. Building more advanced statistics into the TGVE again is one of the future directions of work. TGVE comes up with some standard, if you like, charting visualizations of your loaded dataset, but this can be enhanced and improved. One of the big chunks of work could be auto-fetching geography data. This really will change any application, I believe. Supporting multi-layers, I'm not going to dwell too much on that, but also as AI is exploding around us, also using AI to get rid of even more manual steps of geospatial data processing and visualization. And that brings me to the end. Thank you very much for attending this session. I am here. I will welcome your questions.